Good morning, SE student. This is your math teacher, Monsieur All. Our lesson today is also about exponential function, the third part of this lesson. First of all, the derivative of f of x equal ex. I think this is the only function that its derivative equal to it. So we notice here if f of x equal ex, then f prime of x is also what? Ex. Here I have f of x equal ex, and the derivative function is also equal to ex. This is, I'm going to give it to you as admitted without proof for the SE students. Now, if f of x equal e exponent ux, this means I have many terms or many factors or whatever here other than x alone, so the derivative function will be f prime of x equal u prime eux. As an example, if I have f of x equal e exponent 3x, then f prime of x equal 3e exponent 3x. I took here the derivative of e exponent 3x. What about f of x equal e exponent minus x? Then f prime of x equal minus e minus x. Now, another example here, if f of x equal e x exponent 2, then f prime of x equal 2x e exponent x squared. Now, as an example, I'm going to give you an example here. F of x equal ex minus x plus 5, then the derivative function, the derivative of ex is ex, the derivative of minus x is minus 1, and definitely the derivative of 5 equals 0. Then the derivative of f of x equal ex minus x plus 5 is ex minus 1. What about x ex? You know that this has the form of u times v, and uv prime equal u prime v plus v prime u. Then we can deduce that x ex, we take x as u and ex as v. Then f prime of x equal u prime, derivative of x equal 1, u prime v minus v plus v prime u, which gives us ex into 1 plus x. What about f of x equal ex over x? This has the form of u over v, and we know that u over v, derivative of u over v equal u prime v minus v prime u over v. So ex, the derivative of ex is ex itself. U prime, this is u prime v minus v prime, the derivative of x is 1 times u over v square. So by simplification we get x minus 1 ex into ex over x square. What about f of x equal x square plus 3x plus 2ex? Also, this has the form of u times v. This will be u and this is v. So I can take, as I said before, u, this factor is u and this factor is v. U prime 2x plus 3 into ex plus v prime, which is also ex, into x squared plus 3x plus 2. By simplification, we obtain f prime of x equal x squared plus 5x plus 5 over ex. Another example here of the form u over v. We notice here that the numerator is ex plus 2x, the derivative of ex plus 2x is ex plus 2, into v, which is ex minus 3, minus v prime, the derivative of ex minus 3 is ex, into ex plus 2x over ex minus 3 square, and by simplification we obtain f prime of x equal minus 2x ex minus 6. Now, in part 6 here, I have also f of x of the form u times v. But here I notice that v equal e exponent minus x, and as I said, this is e exponent ux. So v prime equal minus e minus x by using f of x equal e exponent u, then f prime of x equal u prime e exponent u. So we obtain here 2x plus 2 into e minus x. The derivative of e minus x equal minus e minus x into x squared plus 2x plus 1. This gives us e minus x into minus x squared plus 1. 7. F of x equal x squared plus 2x plus 1. Also this has the form of u times v, but also here v equal e exponent 0.5x. Then the derivative of v, this has the form of f of x equal e exponent u prime. The derivative of 0.5x is 0.5 e exponent 0.5x. F prime of x in this case becomes 2x plus 2 e exponent 0.5x. The derivative of v, as I said before, 0.5 e exponent 0.5. Of course, here I have x, I missed x here, into x squared plus 2x plus 1. By simplification, we obtain f of x equal e exponent 0.5x into 0.5x squared plus 3x plus 2.5. Now, what about the limits? By using in the previous video, you saw that, or in the first video, in fact, you saw that when x is approach negative infinity, the value of ex becomes 0, and I gave it to you. In fact, limit of ex when x tends to negative infinity equal 0 plus. This is the first rule. When x tends to plus infinity, limit of ex when x tends to plus infinity equal plus infinity. And here I have ex. When x tends to negative infinity, the answer is 0. Well, yes, in fact, if we replace it, we obtain for x minus infinity, and we know that e exponent minus infinity equals 0, as I told you before, e exponent minus infinity equal 0. I'm not going, this is not allowed to write it, but we can understand it that e exponent minus infinity equal 0. Now, what about this? Has an indeterminate form. What I'm going to use to get rid of this indeterminate form? Of course, I cannot use factorization because it's all already factorized, or expand. There is no plus or minus here to expand, to use expansion. So I need to use L'Hopital's rule. But also here I don't have 0 over 0 or infinity over infinity. I can transfer ex to the denominator. This becomes x over e minus x. Now, if we substitute x by minus infinity, we obtain here e exponent minus infinity and 1 over e exponent negative infinity, which is 0 plus 1 over 0 plus infinity. So we obtain infinity over infinity. Then in this case, I can use L'Hopital's rule. So by using the derivative for this one, we obtain x over, of course, we start by x, the derivative of x equal 1. The derivative of e minus x is minus e minus x. In this case, this becomes 1 over minus e exponent minus infinity. I think here I have minus. So the answer is 0. So you can directly use it that when x tends to negative infinity of x ex, the answer is 0. Directly we can use it. Now, here, if we have ex over x, when x tends to infinity, the answer is infinity. But in fact, it is equal infinity over infinity. E exponent infinity gives us infinity, and when x tends to infinity, and x equal plus infinity. So we have indeterminate form. By using L'Hopital's rule, we obtain limit of ex over x equal ex over 1. When x tends to infinity, e exponent infinity equal plus infinity. The last one in the limits rules, we have part 5, limit of ex minus 1 over x when x tends to 0 equal 1. Why is that? In fact, when x tends to 0, this becomes e exponent 0, which is 1. 1 minus 1 equals 0, and this 0. Using L'Hopital's rule here, we obtain ex over 1, which is e exponent 0 since x tends to 0. E exponent 0 over 1, which is 1 over 1, which is equal 1. By the way, for limit of ex over x, even if here I have an exponent alpha, the answer remains plus infinity, but in condition that alpha is greater than 0. And also here, if I have limit of x e x, and here I have alpha, when x tends to negative infinity, the answer is still 0, but also in condition that alpha is also greater than 0. Now, examples. When x tends to negative infinity, find the value of x minus 7 plus 5ex. When x tends to negative infinity, I have here negative infinity, negative 7, and 5 times 0, because limit of ex when x tends to negative infinity equals 0. So negative infinity minus 7 plus 0 equal negative infinity. But what about plus infinity? Also here I have plus infinity minus 7 and the plus infinity, since ex when x tends to infinity equal infinity, so we obtain also infinity. Now if I have when x tends to negative infinity for x minus 1 minus 2ex. In fact, this is also negative infinity minus 1 minus 0, but what about plus infinity? This is infinity minus infinity here. So we have here an indeterminate form. What can I do? I remember that when x tends to plus infinity, I have limit of ex over x when x tends to plus infinity equal plus infinity. So here I'm going to use it here. I take x in common here. I have here x minus 1 over x, 2ex over x. So 2ex over x gives us plus infinity using this rule. So I obtain a plus infinity into 1. Of course, 1 over infinity gives 0. So the final form is plus infinity into negative infinity. We obtain what? Negative infinity. Now we have here x plus 2e minus x. And when x tends to negative infinity, we have here negative infinity plus 2 gives us negative infinity, and e exponent plus infinity. Why is that? Because this is negative infinity. We obtain negative infinity times plus infinity. Here we obtain negative infinity times plus infinity. The answer is, of course, negative infinity. Now we have x plus 2e minus x. When x tends to plus infinity, I notice here that I have in the first factor plus infinity plus 2 gives us, of course, plus infinity. But in the second factor, I have e minus x, which means that this is e exponent negative infinity. Every time I say that, I'm not going to use it. But e exponent negative infinity equals 0. So the final answer is negative infinity times 0, which is indeterminate form. So I need to use L'Hopital. Since we have here e minus x, I can put it in the denominator. So we have limit x plus 2 over ex. When x tends to plus infinity, this becomes infinity over infinity. We can apply L'Hopital's rule. Derivative of x plus 2 equal 1. Derivative of ex equal ex. So the answer is 1 over infinity, and we obtain 0. What about limit when x tends to plus infinity of minus ex plus 5 over 3ex plus 2? By substitution, ex when x tends to infinity is plus infinity, and here I have negative infinity. The answer is negative infinity. Here 3 times plus infinity equal plus infinity. Infinity over infinity indeterminate. We can use L'Hopital's rule. We obtain minus ex over 3ex. So by simplification of ex, the answer is minus 1 over 3. 8. Limit of 2x plus 3 plus x plus 2 over ex. The answer is infinity plus 3, and here infinity over infinity. I can apply L'Hopital's rule only for this term. In other words, for this term. So when we apply L'Hopital's rule, we obtain 2x plus 3, 1 over ex. 1 over infinity equals 0. The answer is plus infinity also. That's all for today. Thank you.